I'm very excited to be speaking on this platform, and I think just to give you a bit of an idea of who I am, I'm a farmer's son from East Lothian. Probably not farming for as long as many others have been on this in this meeting. My background, I have to admit, was that of a chemical agronomist. But being a middle son, my older brother got the farm, and I went off to Australia in a huff. And it was there during some my years in chemical agronomy that I had the epiphany that this method of agriculture just simply wasn't working, and that there had to be another way. And the reason that it came to my absolute realization was when I saw two individual friends who were farmers actually walk off the farm and having to hand the keys back to the bank. And it was simple as this: they ran out of soil carbon, without which nothing actually works. So it's over the years I've picked up a few ideas and picked the brains of people who I consider to be much more knowledgeable than me, and also observed some of the best farmers around the place, and have come up with a certain idea on it. With regards to organic, the way that the current system is moving, I see no reason whatsoever that there shouldn't actually be parity with organic yields to what we've come to define as conventional farming, which I think is actually quite a shame to call it conventional farming, because really what it is actually probably best described as industrial farming. So I'm just struggling to change my slide here. Just want to check though, has everybody seen that slide change? Has it worked?
Yep.
Yeah, it's worked.
Okay. So I've got conventional farming there in inverted commas, because really what it actually is going completely against nature's way of actually growing plants. And that's what we really need to, I think, come back to the common denominator of to focus on, is actually growing plants. We tend to do monocropping. I'm saying we, because I'm part of the problem of chemical farming in the past, ignoring the incredible relationship between plant roots and the soil, which is the microbial bridge, and it tends to be completely ignored and taken for granted within the conventional / industrial farming system. And if when you go to a conventional farming meeting, you come away with the impression, well, it's impossible to grow plants without hydrocarbon-based inputs, and it's always based on it's always based and definitely sold on the fear that if you don't use this, oh well, what's going to happen? So you can see just by my, well, it's not mine, it's actually a graph from Pete Ainetta from the James Hutton Institute that shows that it's really in the last 20 years, the average yield of some of their main arable crops hasn't actually changed significantly at all, but the actual inputs into them have probably increased by around about 20 to 30%. And then all of a sudden, just this year, it's brought it into very sharp focus when the cost of those has actually multiplied up to 4 times. And throughout when I'm speaking, I think it's always this little proverb in the corner is always to think, well, what are we actually going to leave? What's our legacy going to be from farming? That we have to leave something that better than we found it. So it's always important, I think. So having a quick look at where we are as an agricultural industry. Now this does obviously relate more to the industrial model of farming, but it is the absolute definition of unsustainability. And it kind of annoys me when I hear these greenwashing terms when you've just got certain conventional agricultural bodies using words like resilience and sustainable, because it really is the opposite of that. Now, we as an industry, we have to understand that, hydrocarbons are running out. As organic farmers, that's something that has to be considered as well, given that we're using horsepower to farm. But the biggest problem is the blanket of mixed greenhouse gases high above in the atmosphere, which is stopping the escape of heat from the planet. These being largely carbon dioxide, and agriculture on a whole is responsible for up to 25% of all those emissions. Now, I will go into why the worst part of that is, but also we're big emitters of nitrous oxide and methane, which in their own respective terms are actually even worse than carbon dioxide in terms of being insulating gases. Now, you've all probably seen this, maybe as little as 60 rotations left, but that's taking an average over the world in places where they don't actually have a great deal of soil humus left. But when you see enormous areas, swathes of the world returning to desertification, then we need to put an end to this. Now, we can't sort of look in the mirror without actually looking at organics as well. Because in organics there are often some mistakes there. Well, sorry, it's a bit rich. There is a contribution in terms of soil carbon volatilizing into the atmosphere as well, and that is the use of tillage. And it's not natural for soil to be tilled. When you introduce too much oxygen into soil, then you get combustion of the organic matter, and it volatilizes as carbon dioxide. That said, we do require an amount of that, but we always need to have a crop or some sort of plant on top in order to capture that in the stomata, which are on the underside of the leaf. So most of the carbon dioxide from which a plant is feeding is actually coming from the soil. That's why nature has evolved to have the stomata on the underside of the leaf, not from the top. So when we talk about sequestration of carbon dioxide, that's really something that relates to trees. It's not really relating to arable cropping. Most of it is coming from the soil. So we actually have to stop this leak of a great asset. So the starting point from there, and this is say maybe something in organic, which conventional farmers can also be, probably a point which we probably ignore too much, is our starting position. Looking at things like the cation exchange, pH, there are key ratios referred to as the Albrecht ratios, which you never quite get, but it's something to always aim for. The organic matter status is not a target. It's somewhere at any point during your rotation, you should be able to say, yes, I have more this year than I did last year, or I have more on the average over 5 years of my rotation than I did when I first started out, to try and improve it and improve the efficiency of the farming. Some of this will require this nutrient balancing will require trace element to rectify trace element deficiencies. And when you've been farming for a while, these do run out. There are enormous abundance of them available generally in the soil, but they might not be within the depth which we can realistically farm in the time we have during a season. And so we need to ask the soil, what are these imbalances? And I would suggest that the most detailed soil analysis that you can get is where you start. They're not particularly cheap, but when you put it into the context of some of the inputs or some of the wastages, the leakages in the system you didn't know you had, is well worth doing. And then we can also evaluate what we have in terms of the actual texture of the soil. Are there any soil remediation techniques required to stop capping, for example, or to improve the actual structure, the crumb structure of that soil? And generally, when you're in organics, you do actually have better organic matter, and as due to no synthetic nitrogen, that's the big one there. So ultimately, this story, as in any story in agriculture or anything to do with actually growing plants, is all about the carbon cycle. It's everything else is really just a tag onto that. You're all familiar with photosynthesis, but it's the 30 to 50% of sugars produced by some plants produce more, some produce slightly less. That's actually fed down through the phloem. The vascular tube used to be called leaky roots, I believe, decades ago, and that feeds a whole plethora of microbes down in the soil. There's also down in the soil, there's a whole heap of other microbes that were actually breaking down last year's and previous year's organic matter and recycling that into building blocks that a plant can uptake to make the latest crop. And so we have to become pretty competent at that as well. Simplifying it right down, as Roger said, okay, you have to, rather than thinking, well, my view anyway, is rather than thinking of yourself as a farmer, think of yourself as a chlorophyll manager. And so if you can increase the quality and the density of chlorophyll in whatever plant that you're doing, you're going to make that plant grow significantly faster and significantly more in a resilient fashion. Basically meaning in the face of adversity, it can put up with whatever is there. And the two main ingredients within that are carbon dioxide and water. With sunlight as a catalyst and with the plant, it's incredible. We can just take advantage of this amazing process that's been handed to us called photosynthesis. So to try and limit some of the factors that would limit photosynthesis, what are those? So obviously lack of carbon dioxide, lack of water, lack of sunlight. So how do you how can you maximize your use of sunlight? Well, there's having a reduced photosynthetic panel, a platform, solar panel. Half the time when we're growing a crop, when something's 2-3 leaf, you're probably only using around about 10% of the soil is actually covered with a green area index. So should we be using kind of more companion crop in that, for example? Cover crops are a fantastic opportunity to try and put down a whole multitude, a plethora of different types of root exudate. That's the sugars that have been exuded, squirted down through the roots to feed each root exudate has a different flavor, and it feeds a different spectrum of microbes. That whole spectrum of microbes together will be the ones that actually can compete with things that you or we consider to be pathogens. Actually, incidentally, a lot of these things which we consider to be pathogens are actually just the microbes with the shortest life cycle. They're the first to recover after, we say, for instance, we've ploughed, or in conventional farming where they've applied some pretty nasty pesticides or a whole heap of salt, which is most fertilizers. So what you see there actually is just nature's way of it's decomposing above ground. So it's a different way to actually look at it. So some of the things we can actually we seem to waste an awful lot of carbon dioxide by not having a plant always there on the surface to take advantage of the carbon dioxide which is escaping up through the soil as the decomposition bounty from decomposition which is constantly happening. We can also waste an awful lot of water by having capped soils that we're not making the most of this being absorbed into our soil. For a soil, for every 1% of humus that you increase in your soil, that soil can hold an extra 170,000 litres of water per hectare. So if you run into sort of drought conditions, if you haven't been absorbing everything that is possible down to a great depth, then sometimes we only have ourselves to blame. I'm not saying always, but quite often the case. And gas exchange, allowing oxygen in and carbon dioxide out. This is where we have to get on top of capping. Now, once that's actually in the plant, there are certain things such as manganese deficiency. Without a decent amount of manganese in the soil, then that plant can't hydrolyze water. It can't split water to make into the oxygen and hydrogen components in order to make a carbohydrate, which it requires to do in order for it to grow. And sometimes there are certain things that may need to be addressed. And that's why there are at times a time and place to apply for a derogation to make sure some of these trace elements are actually available as cofactors, as enzymes, as elicitors for various things. And sometimes that's hormone manipulation for what the plant is trying to do at the time. So in conventional, I'm sorry to compare sometimes to conventional farming, but there's, they tend to focus on mineral inputs. And when I speak to a few organic farmers, they'll often say, oh, well, we don't get to use, these extra mineral inputs at the rates that conventional farmers do. And that's not always a great thing. When you look at the actual stats for what you're allowed to put on 225 kilos of nitrogen per hectare, well, the actual use efficiency of that is anywhere between 10 and 40%. It's extremely low. The rest of that is not just wasted, it's actually polluting. And with it, it's probably taking around about up to 50 times as much carbon from the soil. And that's because there are a whole heap of microbes actually feeding on that nitrogen to make proteins of their own. They exhaust their resource, and then they die, and then they decompose, and boom, the whole lot goes up into the atmosphere, through the soil, up into the atmosphere. Now, of course, some of that is captured by plants, but not always. And if we have a lot of bare soils, then there's nothing there to capture it. So a plant will never really use a straight mineral. It'll never really use just that single element on its own. It's always something. It's always trying to make it into an organic complex. It's always trying to look for the most efficient and time-efficient way in order to basically to make proteins. There's now, if you're just to go and add straight nitrogen to a plant, it has to try and, it's not actually a very good way to make a protein. It has to spend a lot of time and energy actually making it into something that it can use. I often use, if you don't mind changing the slide again, I often use this analogy here. This is an old IKEA advert from years ago. Now, the guy walks in, take a seat, it's going to be pretty short, easy exercise to do. But if you actually have to make it, spending time and energy to do so, that's what the plant is actually really having to go through. So a plant will actually can take up to building blocks up to 1,000 moles. That's just a way of measuring the size of a molecule. So in nature, when we break things down into back from proteins back down to amino acids, that's the form that the plant will most readily take it up. And the best way to deliver those is actually through this whole world of bacteria and fungi, which will feed the soil, will feed the roots with the nutrition that it requires at the time. And that will change probably for probably only a couple of weeks or so, that those certain ratios of nutrients will actually be required, and then the plant will change its mind as it changes the growth stage. Now, the first of probably I think the most important organism in the world these days is mycorrhiza fungi. I'm sure you're all very familiar with mycorrhiza, so I won't go into them too much, but this is an absolutely extraordinary fungus that will colonize the roots when the plant actually asks it to. And the exudate, the sugary substance squirted down to the roots, is actually a chemical signaling as well, and it's a plant's way of waking up some of these mycorrhiza fungi, which will act in conjunction with different strains of bacteria to deliver the form and the size of molecule of what that plant is looking for in the first place. Now, if we've addressed nutrient imbalances in the soil, then these mycorrhiza fungi can deliver these to the plant really quite readily. And phosphorus is the one that plants find particularly difficult to deliver. When a mycorrhiza fungi delivers phosphorus, it also delivers everything that the phosphorus was attached to as well, and usually that's calcium and magnesium and other major sources of nutrition for the plant. Magnesium, particularly it's the center molecule of chlorophyll, and calcium is responsible for about another 7 elements actually being capable of passing through a cell membrane and into the cell. The other thing that happens when you get mycorrhizal colonization is that the root cortex, which you can see in the top right-hand corner there, will actually thicken up, and so that makes you more resilient to the likes of any form of root disease, being brassicas, it could be clubroot, it could be take-all within cereals. So anything that's going to limit your uptake of both water and minerals to the plant. Now, one of the other great things about mycorrhiza is that in order to function, they will actually produce this sugary polysaccharide glycoprotein. Sorry, I don't know why I bothered mentioning that. It's not necessary. And it's basically it's just liquid carbon. And what it'll do is like a flexible lattice. It will secure all those soil colloids and stop all the nutrition that are hanging from that soil colloid from escaping. Then the fungal hyphae come through and extract the exact ratio of what the plant needs per its growth stage at the time. And then the plant will actually signal again and kill it off. But that sticky, flexible lattice will actually stay, and it's quite stable for quite a while. And that's where you see as the root dreadlocks that you can see in the two pictures on the right-hand side, and that's what's sticking the sand to that root down in the bottom right. So if you dig up some plants and you can see you've got that, you're doing pretty well. Now you'll also notice that the one where you can see my hand there, these are actually from cover crops. So quite often you'll see this happening an awful lot more in cover crops because there hasn't really been a great amount of soil disturbance beforehand. That is in a conventional system, but in organics you might actually be seeing this really quite readily. Now, I mentioned before that the mycorrhiza don't always just act alone. They'll actually have the aid of bacterial partners, which will solubilize things into smaller components and then deliver it into the mycorrhiza. And as the mycorrhiza move through that soil profile with the root, so they're only really happening within about 3 millimeters either side of the root. As they move, these bacterial colonies will hitch a ride on the back of some of these fungi and some of the breakdown of what we call saprophytic fungi. But you can actually use just these bacterial partners on their own. This is an example, and I promised Deb that I wouldn't talk about any commercial products unless they were actually available for organic users to grow. And this thankfully is something that is available for organic growers. This is a oilseed rape crop which is grown at Archerfield in East Lothian. It's not been, the soil there has not been in a great way for a few years after probably I think you could describe it a fairly invasive potato crop that was there. It's not the fault of the person who had the rental of the land for it. It's just not great land for it. It's quite heavy clay over sand in the areas where these 4 fields are. And so it was this oilseed rape crop didn't come through particularly well. It was very slow. It had the water to do it even despite a dry year. But we inoculated it with a concoction of nitrogen fixing and phosphate solubilizing bacteria. Now, okay, this is conventional we're looking at here. So it did actually have 30 kilos of N on it as well, but so did the one over on the other side. They've both had exactly the same, but the one on the left at Archerfield has had these nitrogen fixing, phosphate solubilizing bacteria applied. So even where you can see just straight nitrogen applied, you can see a bit of nitrogen deficiency, sulfur deficiency. Somewhere in the middle, I did see a bit of purpling, which could be, again, a sign of sulfur, but also of phosphorus deficiency. Now, one of the tools that we use in regen farming, or any farming really, to test overall health, test overall sugars that you have in a plant is a refractometer, and it gives you what's called a Brix reading. If you've got a Brix of 12 or over, you're doing pretty well. You're not really got an awful lot to worry about. You're producing good quality sugars in there. And you'll generally get a better reading later on in the day when the sugars are at its highest, probably about the end of the day. And obviously you'll get a better reading as well when you've got stronger sunlight in summer. So the Brix of the one on the left was 11 and 3 on the other one, taken pretty much the same time of day. So it just shows you that anything that is delivered, anything that is had its nutrition delivered by a microbial partner is always, always better. So to give you a bit of an idea of what that costs, okay, this is up to date pricing on a liquid fertilizer 190019, which is liquid urea with sulfur in it, compared to this product called Microforce, which is just a concoction of bacillus bacteria, and also Azotobacter, which is a pretty pungent nitrogen fixer. So part of the reason it's so cheap is because they were brewed up at home in an IBC. And in order to brew them up, you could have certain things to give them something to feed on. And that was a seaweed extract, fulvic acid, and some aloe vera. And there was also, actually in that as well, there was 10 litres of molasses, which was costing 30 pence. So it's per litre. So it's not a huge amount on top of that. So 30 quid. But cost per hectare, £11.36 for something that over the course of the season is going to likely fix around about 30 to 60 kilos of nitrogen as an ammonium nitrogen in the ground. And that's the form that a plant would actually prefer to uptake nitrogen from the soil. When you use nitrate fertilizer, nitrate is actually very energy inefficient for the plant to use. So thinking back to that IKEA analogy, sorry, I shouldn't say IKEA, just that making up a seat analogy. So it actually requires 3 times as much water to try and make that nitrogen into a protein. Their plant then becomes very watery and very susceptible to disease. With ammonium, it's the rate that the plant should actually be using as long as it's available. Look at the price difference for something, and you can see the actual result there. I think I'd rather have the one on the left, and I'd certainly have the price tag for the one on the left, £11.36 per hectare as opposed to 90 quid. So there's when it comes to organic as well, sometimes I hear quite a few people saying, well, you know, these other guys, they've got crop protection, they've got something they can just spray on it in the form of fungicides, etc. Well, that's not always a great thing. If the nitrogen that the plant is actually receiving is in the form that the plant needs, and therefore can make complete proteins because there isn't you've done your mineral balancing in the soil, and so it can make complete proteins. And another way you can actually just do is actually just to increase the cell strength. And one of the ways that you can do that is just boosting silica and calcium in there. There's a product. It is it's a soil association, obviously just because it's an overall UK body that it's actually registered with them. It makes an enormous difference in boosting cell strength, and used it a lot in convention as well, instead of a fungicide. So there's this is just in quite a few regenerative programs, it'll probably get around about 4 applications of that in a year, and you might have to go in slightly at the end with a fungicide in extreme situations. And if I say extreme situations, that's me trying to be kind to myself, saying I've missed something out and I haven't quite got it right, because it shouldn't really need anything at all. So some of these tools are available, and we can do an awful lot with regards to disease prevention as a result. The other thing is about that product there, DiaLife. It'll actually improve cell strength to the extent that it stiffens up a crop, stiffen the straw to the extent or even stronger than a growth regulator would. So it was put into, the guys who supply me put it into a growth regulator fungicide trial over in Northern Ireland, and somebody in all the wisdom managed to leave out the fungicide and the growth regulator, so this was just done on its own. It ended up, the crop was probably about 15 centimeters taller, but it was the stiffest one there, and because it hadn't been, there was a slight mess up, they couldn't actually declare what it was. So nature's way is, in my view, is always the best. So some of the other ways that we can increase the resilience and the overall spectrum of microbes that will feed doesn't have to just be through a cover crop. Polycropping, herbal lays, for example, it is deficient, it's a working cover crop. The protein that you get from this, can be up to early 20s in percentage of protein. It will ensile, it will deliver a whole different spectrum of shapes of roots. There's a whole shapes of leaves as well that are capturing so much more sunlight than any monocrop of grass. If it's just ryegrass, timothy and clover, for example, you put in 3 different legumes, you put in a whole heap of, you've got different shapes of roots and everything as well. It just fills up that space so much more. Stock just do so much better on it. And again, you've got, say, in one of the ones that we sell, it's about 15 different species in there, and it's incredible how the soil reacts to that, of what it's actually being fed. Polycropping in the form of cereal and legumes, bringing sort of more beans and peas into the system. This is something that I think will probably be the halfway house for a lot of farmers, and we can actually increase the amount of nitrogen fixation from legumes if we try and address some of the minimal factors in there, like molybdenum, cobalt in the soil. We can get these rhizobia to fix a great deal more, and at the end of that, multigrain separators, I think, are going to be quite a game changer in this area. So you can manipulate the ways that these bicropping techniques can actually mature. You can get beans to mature a little bit quicker. You can, or either that, or you can just go for two harvest times. Maybe not ideal for some, but sticking it through a multigrain separator is something I think could be quite a game changer. Now, you'll also find as well that when you have multiple crops growing together, they tend to try and produce more of a sympathetic maturity date. So what's something you'll find that perhaps barley might hang on a little bit longer, and that beans or peas might mature a little bit faster. Not particularly sure why that works. I can only probably put it down to the fact that it's an interaction with different microbes in there. That would be my guess anyway. But you can also manipulate it slightly with trace elements. And so Another technique, living mulch, clover or lucerne that are strip tilled. These things don't need to be, hear people saying, "Oh, I want to go and kill it with the horrible Roundup," and you just think, why are you doing this? And you strip till into it, or say, for instance, you wanted the lucerne to grow a little bit slower so that your cash crop could come up through it. Well, these they don't like being sprayed with nitrogen. Obviously, you can't do that within organics, but you can apply an amino acid, which will slow it down considerably. It'll stop the fixation rate quite as much, slow it down, strip till into it. As long as you've got chosen a legume partner which is relatively shade tolerant, and when it's harvested, you've got something already there. What you're doing all the time is making sure you don't have a bare interrow. You're not losing carbon dioxide. You're not losing volatile nitrogen from the system. So preventing all these leakages happening, it just means that you don't need to. You may not need then to go and put on the additional cost of a heap of free living nitrogen fixers. You're doing it by other natural means. But really what I'm highlighting there is there are options there for you to be able to get as much or enough needed nitrogen in the system so that you don't actually feel, just because I'm organic, I'm not getting what I need to. That's an idea of the living mulch there. That's an oak crop with lucerne grown underneath it. That was it in its earlier days. And you can see there using a wider row spacing there, just to allow to make sure that companion crop isn't actually getting outshaded. So it may require you taking an ever so slight yield hit in that first little while after in that first application during that of that technique in that rotation. You can bring it in slightly. You'll get an idea of what actually suits your system. This is the other thing you must become very proficient in, is decomposition, is recycling the nutrients that are already there in the soil. I think everybody could probably say at some point in a farming career that they've seen dung or straw ploughed up from 2 years before that hasn't actually decomposed. That's an indication that the decomposers either aren't there or that the decomposers can't breathe. So we need to get that gas exchange sorted out. So that might not be, that doesn't mean go in there with a plough and a power harrow and try and batter the soil into smaller particles. This is happening on a much smaller colloidal, like piece of soil, whether it be clay, silt or sand, a soil colloidal stage. I'm just going to nip to a slide in front and then go back to this one. So this is a slide made up, so it doesn't look very professional, but it was me that did it. That's why. So one of the ratios that I mentioned, that I didn't mention, sorry, I should have mentioned earlier on, called the Albrecht ratio. The first one that's so important is the calcium to magnesium ratio. On the cation exchange, which is if you look at one of those pieces of soil, as it doesn't matter what it is, it doesn't matter if it's sand or it's clay, whatever, it has an electrical charge on the outside of it, much like an old the static on a television. And onto those, the positive parts of the salt, the things that they're called the cations, will sit. If the cation exchange is low, it's just a way of saying the larder's not very full. That means that the non-nutrient part of that, which is hydrogen, is quite abundant. So if the cation exchange is low, it means that your pH is quite high, because higher hydrogen ions in there are what lower drops pH. It basically means that energy cannot be exchanged very well, and you'll find that things are oxidized Okay, oxidized is different to oxygenated. Oxygenated means there's oxygen there available for microbes to breathe. Oxidized is what the doctor is always telling us that we don't want. It means that something cannot pass on energy to other parts of the system. So we need to make sure plenty of oxygen can get in for oxygenation for microbes to breathe, and carbon dioxide can get out for our plants to breathe. And the other thing is, if you get too much carbon dioxide caught up in the system, it turns to something called carbolic acid, and kills quite a lot of stuff. Leaks into the oceans, not good for the bodies of krill and things like that. So the calcium-magnesium ratio, calcium is a much bigger atom than magnesium. So as you can see by the blue disc there in the middle, as opposed to the red one, magnesium. So if that, and they are the ones that have two arms, called a valency of 2. If you have plenty calcium, then as you see by just below the arrows, that's the gap between your soil colloids. If you have too much magnesium, which was often the case when magnesium lime was applied, which was the best advice at the time to stop staggers in cattle, the soil became very tight. Now you can't just get rid of that. The only way to get rid of it is to add gypsum, which is what the calcium sulfate is down in the bottom. Now the anion, the one with the negative, I promise I won't get any more technical than that. The other part of the salt will always react with the cation, which is the lightest, and that's the magnesium. So it will form Epsom salts, which will either get taken up by the plant and make it nice and green, because as I mentioned before, the magnesium is the center part of the chlorophyll molecule, and the calcium, being free now, will move that bottom soil colloid away, and you'll have much better gas exchange. You'll also have better drainage, and you'll find that your soil will be much lighter to work, to the extent actually where I've heard farmers saying when they ploughed half a field that had been applied with gypsum, that you can actually hear the difference in the tone of the strain of the tractor. So that's maybe something, the best way to correct your gas exchange and the pliability of your soil. So one of the things that we can actually use for that is a facultative anaerobe. I'll maybe get into that if we've got time at the end. But the easiest way to apply that, okay, is so a facultative anaerobe is something that will decompose when there's air there, but it'll ferment things when there's no air there. So you'll have heard people saying, well, aerobes are good, anaerobes are bad. But it's never that easy, because if it's been raining for 2 days, then it's anaerobic. And so at that point, these things will ferment things to take it halfway, really. And once it dries out, they'll switch over to doing the anaerobic decomposition. And that's all it's doing, is recycling all that nutrition that is there and breaking it down into smaller blocks to something that your cash crop can actually use. Okay. And I probably don't think we need to go into explain that in an entire soil food web. There are a few products that you can use to sort of to help facilitate a few of these techniques that I've done. I'm not going to go through them all because each one of you will have a different situation that something else could apply to. I just put this up because all these products there are all allowed within the organic system. They're either used for allowing decomposition to happen much quicker. Some of them are there actually as a food source to different microbes. Some of them are cell strengthening. Others produce a whole heap of different mucilages that adds a heap of gum to the system, stops things from escaping. Others are fixing nitrogen, solubilizing phosphorus, and so forth. And you can actually apply mycorrhiza and other beneficial fungi to your system. but you've got to get your gas exchange sorted out first. I made that big mistake a few years ago and got a few people quite excited about it, and then ended up really rather letting them down because I hadn't covered a few of those basic rules. And you can test to see where you're going. Get familiar with some of these tools. You can actually see where, using the refractometer, how successful you are as a chlorophyll manager. You can see, well, is that, yeah, I'm producing really good sugars today, or if you're not, then you can actually by a process of elimination see what's not happening. You can test the pH of the sap with a garlic crush, and then go out and say, well, if the pH is low, it's going to be one of my alkalizing cations. So you can then test your top and bottom leaves with a potassium meter. If there's a discrepancy of 20%, we need to add more potassium. There are other techniques there as well. Just letting you know, there are ways that we can do this, and we can rectify the things that are deficient. And so it brings us round to sort of actually completing the system. And the statement at the bottom, so if you've actually got a good friable soil, maybe you've addressed it to get there using gypsum, maybe it was through cover crops or companion cropping, that you are then, those roots can grow much deeper and extract from a greater volume of soil. A greater volume of soil can hold a greater volume of nutrition. Increasing the overall organic matter will hold an awful lot more microbes, and can hold an awful lot more nutrition as well. That's why carbon, as that common medium, that's why it's in your tractor filters, etc., is good at holding on to stuff. That will in itself have create an enormous microbial abundance. Part of that is the breaking down, the catabolic process of breaking things down into building blocks that can be used and recycle better. If the nutrient balance is addressed as well, then even better. You won't have any law of the minimum to concern about. And when you get that, when your plant is photosynthesizing at that faster rate because you become such a competent chlorophyll manager, that's a big statement to make. You don't get disease and you don't get insect attack. The disease can't actually penetrate. The disease basically they're generally decomposers. When they have so much competition from the anabolic microbes in there, the things that build things up, the building ones, the breakdown ones aren't required. And so they don't do anything until there's dead material to break down. And insects will not have their babies on a plant that is so full of sugar that is going to ferment in their stomach and turn to alcohol and kill them within about 3 hours. So you just don't get insect attack either. So back to the question at the beginning, can organic match I'm calling it industrial now, yield? Absolutely. Of course it can. If you become a really good recycler of nutrients, if you eliminate all the deficiencies by addressing some of them it might be by foliar, some of it might be addressing them in your actual soil. Respect that microbial interaction between the soil and your plant. Yes, absolutely. I think that organic yields can match the parity of industrial farming. And we'll leave it at that. No, Dave, I can't hear any of you.
Can you hear me, Dave?
Yeah, I can.
Yeah. Well, I think Deb's asked me to give you a vote of thanks on that. As per usual, that was extraordinary. I learn something every time I listen to you, and I'm sure I speak for everybody that's been privileged to be on the seminar today. That was fantastic, and it's also recorded for posterity. and for sharing amongst other organic users, which I'm sure there will be a stampede to get their hands on that. So again, David, thank you very much for explaining how it can be done in a different way. And you know, we have been farming in a horrible manner for 70 years on the conventional side, and it is time to start protecting the planet and also still enabling us to feed the population. So on behalf of everybody, thank you very much, and I'll pass back to you, Debs.
Thank you, Roger, and just to endorse that, David, that was pretty impressive. And as Roger says, we learn something every time we hear from you. It's actually really such a fantastic opportunity at the moment to redress the way that we think about how we grow our crops. I think for so many decades, and particularly from an organic perspective, soil biology and plant biology was something. It was such a complex subject that we almost were too frightened to look into it because it was too complicated, and so we just reverted to simple minerals and texture and soil structure. But this has just led to us overlooking its importance. And actually, what you're opening the door for us is that there are things we can and should be looking at on the biological side within a holistic view, which for me is the organic way, is that you look at a holistic operation, your farming enterprises all fitting together, and it's trying to achieve that balance between livestock and cropping and rotations and nutrients and soil. So fascinating subject today. And I would hope that the impressive seminar from David there has made up for some of the team's functionality, which has caused a few challenges. I hope everybody's been able to pick out something from that. Really, there's just a lot of stuff that I think we want to explore even further. I think there's a few bits that we had asked you, David, to be keeping it fairly simple for us today because it is just such a massive subject. But what we might be able to do in the future is pick out by farmer vote, people who are in the group to say, look, we want to explore this topic a little bit more, so we can go into further depth and see how we can apply all of those things that you've talked about and touched on today, David, on our farms. And the one proviso I would like to add for the farmers is that don't jump into this piecemeal. Do look at it holistically and make sure, please do your research and get some help where you need it to make sure that you're keeping to the organic standards. You know, as owners of Scotland's organic standards, we have to endorse and encourage you to maintain your compliance. So that was just a little reminder there. Slightly boring. So I had hoped at this point to be able to throw it open to the floor and have some chat, toing and froing about not just David's talk we've just had, but also the future of the group and what we're proposing for a network of all of us meeting more regularly. I feel that might be a little bit difficult, but if there's anybody who does have a microphone and or video and would like to say something, please just jump in. Now I'm going to give you a couple of minutes if there's anybody who can join and would like to say something. If you can't say something, you're quite happy to put something in the chat, because I'm thinking now, where do we go? What is it that you would like to do? And so I'd like to open it to the floor and get your feedback, really. We have a fantastic offer here from AHDB to help us work together, and I would like to find out from you guys what it is that you would like to do, if that's something that's on your radar. Andy, is that your mic coming in?
It's on. I'm trying to think of something clever to say to you, Debs. Probably along the lines as before, getting on farms and seeing people's different approaches that people maybe haven't tried themselves before, whether that's the guys up north who've been growing oilseed rape, or other guys with more companion croppings, etc. But yeah, probably getting on farm and seeing some things happening in the fields that have made a difference. So I guess that's down to your meetings. But so yeah, no rocket science for me, but just seeing things that we could maybe try ourselves, following on from others, or just sharing knowledge.
Cool. Murray?
Can you hear me now?
Yes, can hear you now.
Good. No, it was very interesting talk from David there. Met on several occasions already, and tried some of your product recommendations last year, which worked rather well. Not on the organic unit. So yeah, no, I'm really keen to bring that into the organic system if we can. Really lacking a blueprint from an agronomist, really, to keep us on track and really know what we're doing, because we don't all have time to research the rabbit hole of microbiology. So yeah.
Valid point, yes. And I think also that there's a lot of agronomists who don't have sufficient background in the organic standards. And so sometimes it can be difficult to get that one-to-one advice that's what you're looking for. David, your hand is up. Thank you.
Murray, it's actually not as complicated as you think. If you set the parameters to make sure microbes can breathe, I can talk through that with you. I've walked over a lot of your land, and it's actually generally in pretty good nick. It would actually be quite easy to introduce some of these microbes. I would try them first in your conventional, industrial system. And then roll it over into the organic. All these things in terms of actually growing them, they're not as difficult as you might think. There's kind of spotty people like me that make it sound actually a lot more complicated than it is.
Well, that's very comforting. Thanks, David. Phil, I think Phil Swire, I think maybe you've got your hand up.
Yep, thanks, Debs. Thanks, David. That was really interesting. I was just wondering what your thoughts were on. Obviously, we're fairly reliant often on the plough in an organic system. The plough has benefits, but it also has some pretty sort of disruptive aspects to it, microbial sort of alteration and interference, if you like, structural problems as well. It was interesting to hear you talk about strip tillage. I mean, what are your thoughts moving forward for the organic sector? Do you think we need to move away from the plough?
Don't ever look at the plough as the enemy. There's this kind of movement of people saying, if you're going into a kind of regenerative approach, you have to use straight. The first thing they do is go straight out and buy his min-till machine, and it's just not the right thing to do. If you ever find yourself in the situation where you say, for instance, you look at the soil and you think, well, it's like a chocolate cake, as a lot of folk will say. Well, you don't really need to plough that to create a seed bed, so you could min-till into that. But every now and again, and particularly in organic, you might need to press the reset button, and that's to turn it over. To clean things up if there is an issue with a certain particular type of weed. The other way of looking at of weeds is to say, well, let's kind of create a bit more competition for it, and so they don't grow quite as well when you do have a living mulch there. The living mulch hasn't, it's not sometimes the easiest thing to actually achieve. I think I might ask Graham Elder to come in on that in just a second, because I think, Graham, am I right in saying that you may have tried a couple of times or a couple of options? The other thing with weeds, every single plant is a dynamic accumulator of certain stacks of nutrition. They're experts at just acquiring certain things. If you then, so it's an indication that the soil is saying, well, I'm short of this, therefore this weed tends to grow then. And once that's decomposed and added back into the overall larder, often it's done its job. And I think they're finding this more and more with the likes of blackgrass. It loves nitrate. That's the biggest thing with it. And someone was telling me the other day that when they farmed down south, they were saying, he had all this applying all this nitrate willy-nilly, and his organic neighbour 2 farms over, a very similar soil type, just didn't have it at all. Everybody else had it. So just some of these things to look out on. But if it's not too much to ask, Graham, if you've tried companion cropping a couple of times?
Yeah, we have. I mean, the problem we always had with that was it was managing the competition, and you had areas of the field where you had a level of competition that you were happy with, and then you had areas where there was no competition through you're quite a strong crop, and then equally you had areas where the companion crop had dominated, and you had very poor cash crop. So that's always been the difficulty. I'm always hopeful that some of the new machinery can help deliver something more manageable and consistent. But I've got to say, I've kind of given up on that for the time being. But Murray's got the chameleon. I don't know whether that is a means of achieving that companion crop at a manageable level. But I mean, we're still pretty much attached to the plough. You try to reduce it where you can, but tillage is a big issue, and I don't have any great answers, to be honest. We're still looking, shall we say.
David and Graham, would you agree that when we're ploughing, we plough too deeply, that there's no need for that we should be using a shallow plough?
Yeah, I think obviously the less disturbance you cause, the better. If you can achieve what you need to achieve without disturbing, with less disturbance, then presumably that is a better thing.
Yeah, there's if horses for courses is definitely on that, Rog. But there's I was looking at where was it the other day, and I saw on a long plough, which is a very sort of kind of metre long board, and it's just skimmed 2 inches below the surface and just turned it over. So addressing the weed problem obviously doesn't do an awful lot in terms of taking down a heap of biomass, but graze it bare with sheep and then turn it over. As long as there is something that's been doing the tillage, and that generally needs to be roots that have got down in order to do that. So, horses for courses, slightly.
Adrian, did you want to say something?
Yes, if I may. Debs, thank you. First of all, I just wanted to come in and say hello to Phil Swire, because we've been trying to meet up for about 4 months and still haven't managed it. So hopefully we will manage it in the not too distant future. Just backing up everything that everybody has said, really, in terms of the plough, in terms of organics, it's very difficult to see a future, certainly in the short term, without a plough. I've been on a couple of organic places fairly recently who have done some trials with living mulch, and they're not getting beyond sort of 3 to 4 seasons with it without then having to go back to the plough. Organic farmers shouldn't be ashamed of saying we still plough, and I don't think any farmer should be ashamed of saying they still use the plough. It's got a big role to play. I think it is what it is. It's a tool in the bag, and I think that's how we should view it, really, and not something that should be put in the back of the shed and forgotten about, because I think that's not the view to take.
I think that's what I mean when I was talking about a holistic view. So that if you take your farm or a field over a 7-year rotation, and there's always going to be pluses and minuses, and if you can just reduce the minuses and have the pluses outweigh those, then over that time frame, it's probably the benefits of using the plough, even if we reduce the number of years that we plough, just as David's saying, it might, I don't think we can avoid using it, but there's just very little other ways to get rid of perennial weeds. But it will definitely have a role, I think. But I think we're also, I'm really glad and relieved to hear it being talked about, because it shows that we're aware that we want to move to a position where ploughing isn't the be all and end all, and that if we can reduce that, then we're going to be improving our contribution to sustainable agriculture. So that's a good chat. I did want to pick up on one thing. Graham had mentioned Murray Cooper's chameleon. Murray, would you like to just give us a bit of a description about this this piece of machinery, please, just for those who haven't come across it before?
Yeah, it's a seed drill basically that has a capacity to interrow weed as well. So it's imported from Sweden. Had it since 2019, I think. I've imported it. Getting reasonable results with it. Not fully sold on it, but we've got it now, and it's here to stay for a while. So our biggest problem is stones. So when you go back to weed again, you kick up a lot of stones that you've rolled down. So then that becomes a very painstaking job for usually a couple of people picking off stones. Again, we intended to use it to interrow sow either oilseed rape or grass or anything in between, stubble turnips, particularly in between the rows of cereal crops. But due to the potential risks to the combine, that's been kind of avoided, but we are planning on going back to it again this year. This year coming. On the shallow plough side of things as well, we've visited a few and demoed one, and we have ordered one for the coming season as well. So we'll see how that goes as well.
Well, that sounds like a machinery day visit up to Main to Thornton to see these pieces of kit in operation will be on the cards, if that's all right, Murray. We'll just invite ourselves.
And also just thank you, David, for today. Thanks you, Debs, for it's been excellent. Thank you for the work that you've put in, because I've literally done nothing. So thank you, Debs, and thank you for your team as well. Thank you to Roger for getting hold of David and sorting that out. And thank you for the guys for turning up and participating. And hopefully we can make a success of it. Thank you. Thank you, Debs.